Hello everyone. Today, we will learn about Integrator Block and its definition. How and when to use it in Simulink. Let's start with understanding the concept. Let's open the help for the Integrator Block. So I have already opened the help here. You can see the location in library browser. The block will be present under commonly used blocks or continuous blocks. So I will show the same in library browser as well. Let's check the definition for the integrator block. The integrator block outputs the value of the integral of its input signal with respect to time. Simulink treats the integrator block as a dynamic system state with one state. The block dynamics are given by integration of x of t is equal to u of t. U of t will be input to the block. Y of t is equal to x of t. Y of t is the output of the block and x of t is the x. That is block state. And x at t0 like at initial time stamp t0, which is x0, which will be the initial condition for integration. Initial condition plays a very important role, and whenever we say, there is the output of the integration block is added with the constant plus c. Integration of sin x will be minus cos x plus c. This constant c has an important role in integration. So this all about the definition. Now coming back to MATLAB. I am using MATLAB 2018. I have opened a blank model in Simulink. And in library browser, we will check the location on the block. Search integrator in commonly used blocks. Here you can see integrator. So I will just click it and add block to the model untitled, it will be added to model. Now I'll apply in different type of inputs and check the output on the scope. So first I'll apply a sine wave. I'll keep the amplitude and parameters of sine wave as default. And I'll insert a scope with two inputs, one for input and one for output. Let me resize it. I will connect it to the output of the integrator. And also feed the input, and I will run the model with default solver setting. So now you can see input and output. I will just change the layout so that it's easier to understand. As you can see, this is my sine wave in the range of 1 to -1. This is inverted cos, but it is shifted. But it has started from 0 to 2. Why that is happening? Because I have given here the initial condition of this block as 0. So the input is starting from 0. If I change it to a different value, suppose I make it 1. Enter. And I will run it again. Then you will see the changed output. So -1 to +1, so the initial condition plays an important role. By default it will be 0. We will see in detail about all these properties of the integrator. For now, I will make this initial condition 0 again. Now I have sine wave input. I will now check for cos. So for cos, there is no option like a cos wave, but there is a block called cos. I will just insert this block here. So my sine wave is converted into cos wave and then it is fed at the input of the integrator. I am basically getting the integration of cos. Now I'll just simulate the model. And we'll check the output on scope. So as you can see, the input is cos. We are getting the output which is as expected. Now, I will replace this with constant. For constant, the same value is given, so I will get a ramp as output. I will keep constant with value 1. And I should get a ramp value at the output, that is at the output of the integrator. Now, let's check one by one the properties of the integrator. So we have already seen, what is the initial condition? Initial condition will shift the output on the y-axis accordingly. Suppose if I make it 5. Click apply, OK and run it. The ramp output will start from 5 as you can see here. Then it will increase till 15. So the initial condition just shifts the output on the y-axis. Now we'll change input to sine wave. I will connect it to the input. We'll run the model and check the scope. So it is in the range of 5 to 7. -1 to +1 means the range is 2, so 5 to 7. Thus we have seen what is initial condition. I'll make this back to 0 and also apply limit output. I know integration of sine. It is starting from 0. So it will be from 0 to 2, right? So what if I'd make the as upper limit as 1 and lower limit as 0.5? You can see it will not take 0.5 lower limit. So I will change lower limit to 0. Click apply and OK. So what I have done. Here I have set the saturation limit, so signal above 1 will be clipped off. Let's run it. Now as you can see my output is starting from 0. Whatever portion is above 1 is clipped. Okay, let's change the upper and lower saturation limit. If we consider it start from -1. I'll set the range of signal from 0.5 to -0.5. It will clip whatever part is above 0.5. Here type -0.5 as it at lower saturation. We have to set initial condition as 0, which is within the range. Okay. I will run and check the scope. And as you can see here, our signal is between 0.5 to -0.5. Whatever part was above is clipped off. So that what is the purpose of saturation? Basically, it limits your output. Now select wrap state. I will take constant and we will observe the output. First I will take input as constant. I am going to connect it to the input. It's easier to understand with constant, that's why we changed it. I don't want to limit output. I will keep the initial condition as 0, click wrap state. After selecting this option the output should be reset at 5 and 0. Wrap means it will be reset at the given output condition. So now if I don't select the wrap, I will show you that. How is output and then I select the wrap option again. So you can see it here. Input is 1 and output is changing from 0 to 10 continuously. Now I will say wrap state. I have updated it to 5. So the upper value is 5. So at 5 output will reset and then the ramp will start again. Let's check it. Is the same happening? Yes, as you can see here. It reaches 5, then again. It is reset to 0, and then again it will start increasing. So it is like wrapping output. The output is wrapped around the state. Why this property is given for integrator? Integrators can be oscillators which can be designed using integrator. So at a very high frequency or high output the system may become unstable. So to drop it at a preset value, this feature is used. These were the main features. Now show saturation port and show state port. This option will just show you the ports, so that you can connect it to a scope and analyze the value and debug it. So that's all about the integrator block and the properties of integrator. Now you know how to use an integrator block in Simulink. Thank you for watching.